Music has been around for over 50,000 years, with the oldest instrument being a Paleolithic flute. But it wasn't until the 16th century, though, that the guitar originated in Spain. The guitar has become widely popularized and largely has 6 strings, kind of like this one, though some acoustic guitars have as many as 12 strings. There are acoustic guitars, electroacoustic guitars, semi-acoustic guitars, electric guitars, bass guitars, and many others, including their close string relatives, the mandolin, banjo, and ukulele. Many people play the acoustic guitar, but it can be tedious to tune it. Normally, middle C sounds fluid, but this C is kind of out of tune. It is playing at a different frequency than what it is supposed to be. Each note that is played has a different frequency, as seen with these varying vibrations generated from the guitar. But what is sound? A sound wave is a transfer of energy as it traverses from its vibrating source. A vibrating object, in our case the guitar strings, causes the surrounding medium, the atmosphere, to vibrate. This sound wave moves through the air and its particles vibrate back and forth. The more energy put into a sound wave, such as playing an entire chord, the louder the sound will be. Air molecules themselves don't move across the room like water molecules in a swimming pool. Instead, it's the air that moves through the medium. So far, the sound is just a movement of energy. When does it become what we know as a guitar sound, though? Scientific American has stated that sound is a vibration transmitted to our senses through the mechanism of the ear and recognized as sound only at our nerve centers in the brain. Each note has its own frequency. For example, E has a frequency of approximately 82 Hertz, but A is 110 Hertz. Frequency is something repeated regularly, such as receiving your daily mail or brushing your teeth. In terms of sound, it is the regular reoccurrence of vibrations. And we've been mentioning Hertz a lot. The frequency of a sound wave is measured with this unit. The frequency of 1 Hertz is 1 complete wave cycle in a second, or 100 Hertz is 100 wave cycles in a second. So now let's go back to our terrible sounding guitar. Pitch of the guitar sound is a sensation of frequency. In other words, we cannot physically see the sine wave and its frequency, but pitch is a tangible representation of it that we can hear. The lower the frequency, the lower the pitch. The higher the frequency, the higher the pitch. With knowledge of frequency, we can better understand why tuning that stubborn C is so important.